So next up, we've got Eric Bowen, Director of Product Management at Novilytic. He'll be speaking on, I've developed these introductory statements. My understanding is it's a proteometer technology that brings medicines to market faster and more cost effectively in evaluating proteins with an FC region. And if I'm wrong on that, I hope Eric will correct me.
Thank you very much. Good evening. I'm here to talk with you today about how to eliminate your sample preparation and all method development for your protein analysis, especially for monoclonal antibodies, antibody drug conjugates, fusion proteins with an FC region, and multispecifics. Prior to protein analysis, we typically perform protein A purification, followed by chromatographic purification steps, followed by analysis by either mass spectrometry or size exclusion chromatography, or in the case of direct analysis, with biolayer interferometry, surface plasmon resonance, or some other surface-based method. In either case, we are denaturing the protein as we go about our business right here. And then we are assuming that the protein will renature or return to its original shape prior to analysis. However, we have studies that show that this is actually not the case right here. And also the instruments on the right-hand side are also capital purchases, which require quite a few consumables to run as well. As a matter of fact, here is a list of partial consumables right here that you might need to actually run your analyses right here and your purification prior to. As you can see here, the list is pretty darn large right here. And in this case, some of the items on here are pretty expensive too. So what we are trying to do is to eliminate this right here because the methods can be very complex and they can require analysts with advanced degrees to be able to interpret the results. So this is obviously a great big problem right here, and companies are spending an inordinate amount of time on the consumables. In addition, right here, there are human costs involved here because the method is used by a number of analysts right here. They're wasting a lot of time and money on labor costs. So in every case, sample preparation can be done right here, but it's a bottleneck, and every time you touch a single sample, you risk increasing the error. So Novilytic has invented a solution which we call the proteometer to address this problem. It's a simple kit-based method with only 5 consumables that requires no sample preparation, no method development. The kit provides you titer and aggregate information in a single assay in only 10 minutes directly from your clarified fermentation broth while using your existing HPLC systems as long as they have a fluorescence detector. This results in greater accuracy for your titer and aggregate measurements, improves your process and labor efficiency, improves your AI modeling calculations, and saves you days or even weeks of time as it's highly automatable. And here's how it works. We have a proprietary process called mobile affinity sorbent chromatography. So the sample is injected. It mixes and selectively binds with a mobile affinity selector in solution flowing concurrently with the mobile phase. It then continues to mix and separate by size prior to eluting where it's detected by fluorescence. Because the binding is specific for the antibody or protein of interest, the remaining host cell proteins in solution are rendered invisible to the detector. Here's what one of our chromatograms looks like. As you can see here, we have, As you can see here, we have the aggregates eluting first, the high molecular weight species, followed by the monomer, and then we get some non-specific binding around 5 to 6 minutes, and a trough that results from the binding of the affinity selector to the antibody. We also get some additional information on binding efficiency because of the width of the trough, and we also get some additional information because we get fluorescence amplification. If you notice here, the monomer peak is quite a bit larger than the trough on this. So how does Novilytic's methods compare with the standardized methods? Well, as you can see here on this graph, our method has monomeric purity and average aggregate content that falls squarely in between the typical methods that are used for testing the NIST monoclonal antibody. So that being protein A followed by SEC-UV, or protein A followed by non-reducing capillary electrophoresis with SDS. And our numbers fall squarely in between those as well. The only difference is, in this case, we're testing all of our samples directly in the clarified fermentation broth. We don't have to do the protein A at first. Don't take our word for it. Take the word of one of our customers right here. So this is testing of a bispecific that was done by Johnson & Johnson right here. And the chromatogram looks similar to the one that we had seen previously. So in this case, we actually get partial separation of the dimer, trimer, and tetramer from the monomer. And then we have a little tiny bit of non-specific binding around 5 minutes or thereabouts. Then we have our trough that results from the withdrawal of the affinity selector from solution as it's bound to the antibody. Graph B shows a titer curve right here that was done over a 16-day fermentation run with this particular method. And as you can see, it looks like a very standard titer curve for us. Graphs C and D show the individual peak areas and the peak area percentages for the individual aggregates, the dimers, trimers, and tetramers, the sum of which we just simply call aggregates. So how accurate is the proteometer as a method right here? Well, as you can see here by the curve in blue, we've actually done some testing versus the standard protein A followed by SEC-UV testing. And in this particular case, over the course of a 16-day fermentation run, we get an average of about 2% deviation from the expected titer curve as we go throughout the entire run. However, the same sample that was tested with a protein A followed by SEC-UV gives us about 7%. So as you can see here, we're quite a bit more accurate than the standardized methods right here. So I mentioned to you earlier that we're going to save you a bunch of time and money. Well, here's a little bit of information on how much money we save. Whether you use protein A purification or whether you use direct measurement with something like biolayer interferometry, you're saving quite a bit of money in either case. At the top right here, you can see that we're actually giving about 38% savings over the typical protein A purification costs. We're also giving cost savings over the typical BLI costs, and we also give some additional information in aggregate data with that. And in all cases, there's no sample preparation involved. You just test everything directly in your clarified fermentation broth. Here we go. Here are some of the features and benefits of the proteometer. You'll get titer and aggregate measurements with 2 critical quality attributes in less than 10 minutes, right here, directly in clarified fermentation broth. You won't need any protein A purification or any sample pretreatment at all. There's also no method development, which saves you time and money, and the kit is designed to be plug and play with your existing HPLC systems as long as they have a fluorescence detector on them. So your analysts don't need to learn any new software programs or be able to analyze complicated mass spectra. So stop by and see us here at booth 1625 when you get the opportunity. We're on the far side of the hall over there. And thank you very much for your time and attention.